Welcome to Mass Physics and welcome to VINDAL'S concepts. And let us look at this question on binding energy, or simply called nuclear energy. He said a nuclear fusion equation for generation of power is shown in the equation below. These are different isotopes of hydrogen. This is hydrogen and this is another hydrogen. This one is always seen as a proton, as that kind of hydrogen, and this is another also isotope of hydrogen. That means different kinds of hydrogen that are produced. Even when it comes to helium, we also have different kinds of helium that are produced because of the isotope. Now, he said calculate the energy released in the reaction. So when this atom reacts with this atom, produces this helium and this kind of proton, whereby the first proton is given as this value in U. This U means the mass of measuring the mass of an atom or the nucleus of an atom, because this particular mass happens inside the nucleus. And this one is for another isotope of hydrogen, and this one is for another isotope of helium, and this another isotope of helium. This one sometimes can be seen as alpha particle, and this is the proton, and all the rest of them, whereby we are given C. This is the speed of light, and this is U, called atomic mass unit. It's also represented as U. It's given as 1.7 times 10 raised to the minus 27 kilogram. So let's solve it. For us to be able to solve this, we are going to first say that there is something we call mass defect, because binding energy, according to Alberlt Einstein, stated that the binding energy, the energy used to split the nucleus of an atom, is given as what we call the mass defect all over multiplied by c squared. So the mass defect is also given as, when we talk about mass defect, is given as the mass of products minus mass of reactants. So this mass, we are going to subtract each other. Now, first of all, what is the product? The product is everything in this aspect, and this is the reactant. So everything here is the reactant, and this is the product. So this is reactant. Now, I'm going to take the whole of this, subtract them, take this away from it. So the mass defect is given as, this one is already given as 4.00150 U, plus this value is already there, which is given as 1.00728 U, then minus everything here. This one, this value, which is 2.00141 U, plus this atom, which is 3.00160 U. Now we use our calculator. 301 U. So when we subtract, we say 5.00878 minus 5.00301. So we now say that the mass defect is given as 0.00577 U, right? We also know that 1 U is given as this value, so I'm going to say that this is equal to 0.00577 times 10 raised to the power, not 10, times 1.7 times 10 raised to the power minus 27 in kilogram. So I'm going to give this mass defect in kilogram. So I'm going to multiply this by that value. So this is going to be times 0 times 1.7. So I'm going to multiply this with 1.7. The one that has 10 raised to the power 10, I will keep it separate. So I'm going to have 0.00981 times 10 raised to the power minus 27 kilogram in kilogram. So this is mass defect is the same thing as, I'll write this one in standard form, which is 9.81 times 10 raised to the power minus 3, because this is going to move 1, 2, 3, minus, then times 10 raised to the power minus 27 in kilogram, which is same thing as 9.81 times 10 raised to the power minus 30 in kilogram. So this is the value of the mass defect. So this is the mass of the change in the energy or in the mass of the nucleus of an atom when these reactions take place. So what we are going to do is, we know that the mass defect is already given here. So we are going to now use this square to multiply the two of them for us to be able to find the binding energy that was, or the kind of energy that was reduced in the process. Is going to be equal to, the mass defect is already given as 9.81 times 10 raised to the power minus 30. Then times C is given as 3 times 10 raised to the power 8 all squared. So E is given as, let's square this. I'm going to use this to square this and then multiply it with 8. So this is 9.81 times 10 raised to the power minus 30. Then times, when you square 2 from 3 squared is 9 times 10 raised to the power 16. Yes. So in this case, I'm going to say this ordinary number multiplied by just this number, while the ones that are having 10 as base will also multiply themselves according to law of induction. So the binding energy there is given as 8.29 then times 10 raised to the power 16 minus 30, which is minus 14 joules, but then we have to write this in standard form as well. So it's going to be E is equal to 8.829 times 10 raised to the power 1 times 10 raised to the power minus 14. Why is it 1? Because this point moved one place, so that is why this 10 is having 1 joule. So the whole answer is 8.829 times 10 raised to the power minus 13 joules. So this is the value of the binding energy used to cause this kind of a reaction.